It's 2025, which means it's time to optimize your OBS Studio settings for top-notch quality and performance. Let's jump into let's jump into
Alright, guys. Okay, we are doing that wanted to
It's
be.
2025, which means it's time to optimize your OBS Studio
Can you
settings
hear
for
me?
top-notch quality and performance. Let's jump into
Alright. That works. Let's close this one. Right. So what's up, chat? What's up? Can you hear me? Actually, you can't even see me properly. Uh, let's do it this way. That way I can look cinematic. How about that? Na, 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 na. Okay. Now we talking. So let's start with the CCNA. Before anything happens, I want to close all the tab actually. Task manager. Let's see what's the performance of my computer. So it's been 1 hour. Memory's been alright. CPU's alright. So let's keep it this way. Now we are going for remote desktop, and that's the computer laptop that I'll be using for CCNA. Name of this laptop is, so this is this if you are in a corporate working as an IT, you know what remote desktop connection is. This RDP, this you will be using this a lot every day. Um, Trying to remotely accessing your terminal server, your cloud computer, or your remote computer, or you are helping your user with remote services, you will be using this every day. So one thing, a few of the things I wanted to show about this computer, this application is, um, always go to show more options and it will give you a bunch of options. Display, local resources, experience, advanced. You don't need to know all of them, but this text display, you always want to make it full. If you are a guy, like I recently found out that there's two kind of people for who wants to work in a full window, full screen, and who doesn't want to work in a full screen. So I'm the kind of guy who wants to work in a full screen, so I always set this as a full screen. But some people wants to go, their pixel, their resolutions, blah blah blah, and they can do this. But I always prefer full screen over half-ass screen. And so general, and this is where you go and type the remote computer name. For me, the remote computer is this computer, this laptop, which is uh, desktop 5 years. AJS 0Q, and I can connect, and this will connect. Okay, this that so this error message means your remote computer has some settings that doesn't allow to remote setup. So let me check quickly. Remote connection. Uh, remote stop settings. Okay. Remote desktop it's allowed, and request network level. PCNA data. Can I find a computer? 5SAJS 0Q. That's right, ESKTOP. Ah. You know, this is what we do in IT. Troubleshoot until you figure it out. So ESKTOP 5S AJ 5S AJ S 0Q. Okay, doesn't belong to this specific network. Verify the computer name. Oh, okay. Now you see, I'm in a different network. This laptop is in a Wi-Fi, right? And this is not connected to the Wi-Fi. This is connected to some Ethernet, I believe. And that Ethernet, actually, let me check CMD. See, told you wireless. It's not giving anything for wireless. It's connected to Ethernet, and it's giving me this IP address. For that, let me connect to Ethernet. Connect to Internet. All right. Now, if I try connecting, before that, let me try copy, connect. See, now it's giving me username and password. That means it can connect to that laptop. Okay. Now that user is desktop 25. Yeah, I just write always a random name for my think. Okay, that's wrong. Okay, that's also wrong. What's the password? Okay. I hope this. Okay. Okay, so now this is connected. It's asking for the certificate. Verify the certificate. Something related to certificate. Now, if you check this computer, right? Okay, can you see it? Yeah, so now this is running a screen, and if I don't ask me for connection, if I say yes, this will go on a lock screen. Now, since I have set up this machine as even though if I close the lid, it doesn't happen anything. When I close, you can still connect to this. You can plug in the charger, stash away, but I am just going to leave this open for now. Okay, so as I was saying, this is a name of a computer. See on top, you can always untick this one because I don't want this to keep showing on top. And close. So this usually is my main computer. I have all the software here. What I am going to do now is run a packet tracer. So about the packet tracer, is I have a few other home lab things going on. Keep me logging for 3 months. Cisco Net. The other does actually, yeah, Netcat. Login. You have successfully logged in. You may close this tab. I will. Okay, now I'm in. I can close this one as well. What? Okay. Ow. Hydrate, guys. Hydrate. Hydrate. So now let's go to Udemy. Udemy. Okay, Udemy. Login. Dismiss. So, course material. Alright. I might have shown you when do you want to be ready for exam. Nope. Course material. Please follow the instruction at course to get the study notes. Let's see. And another trick, if you don't want to put email, then temp tempmail.org. ORG. Pam, 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 pam. So first name just RANDOMGUYS. Okay, I just like to do it this way. And once you're here, you can copy and paste. Subscribe. Or you didn't even need to subscribe. Download the course material. Okay, click here. That was my bad, guys. Sorry. Optional. Get the further update. Enter your default from Okay, so what I am going to do is that's a zip file. If I new folder CCNA 200 to 301. That's just my preference to be organized. And so extract here. And another trick about this 7-zip or WinRAR, whatever you use, there will always have an option to click extract here. and that is one of the very efficient way to extract. People would do like double click and they go inside and I can't they would say I cannot open this folder blah 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 because it is zip, bro. You cannot open all the zip folder. You have to unzip first. So study notes, you can go unzip all of these, and flash drive, you can unzip all of these. This you have to in IT. When you are working in an IT, people will always tell you about something. Certainly something doesn't work, is not working. It used to work and it's not working now. What changed? It's a technology. There will always be changes. You just have to try a few different things. I'm not mad about that one because I understand some people are cave people. They don't want to learn new things, and some people don't want to change. Um, it's a basic nature of human, and so that's bring food into my table. So I'm more than happy to help. It just it's just that some people are stupid. So yep, course materials is done. So we can close this. I want to keep that. Yes, the same things. Study plans.
In this lecture, I'll tell you about the study plan. Before I show you it, let me tell you why I've included this. So, quite a long time ago, I was working.
Let me double check. Actually, my okay. It looks like we are onto something, man. Okay, it looks like we are onto something, man. That's what I like to see. Well, it's even though it's only me who is watching. I love you guys.
For a big oil company, and I was based out of an office in Aberdeen in Scotland, and we had the whole floor to the IT department made up of different teams. So I was in the corner with the networking team, we had the server team over at my left, and help desk was over in the other corner. And I used to speak to the people on help desk every day because tickets would come in, and if it was a networking issue, they'd come over and tell me about it, and we would work it out. So a lot of the people on the help desk, they wanted to get on the networking team because it had higher pay, it was seen as a better position. And one day, one of the guys on help desk said to me, so how do I get on the networking team? How did you do it? So I explained that really a lot of it was down to having the certification, and I said the best thing that he can do is get his CCNA. So he said, okay, how do I do that? So I didn't have a training course at the time, but I knew where to get all the resources. So I laid it all out for him. I got all the material, all the things that I'd wasted time doing, stuff that wasn't that useful. I cut all that out and I just told him exactly what he needed to do, laid it all out for him. Anyway, I let him go away and do it. I said, any questions, come and ask me. And about a month later, I asked how he was getting on with his studies. And he said, oh, well, actually, I haven't started yet. So I said, what? And he said, yeah, well, you know, EastEnders has been really good this month. And if you're not from the UK, you probably don't know what EastEnders is. It's a popular soap opera over there. Anyway, I was really disappointed because I put all this work in to try to help him, and he hadn't done anything with it. Now, you've already watched the videos this far, so you're doing better than a lot of people, but I want to make sure that you stay on track. Because really, the biggest buzz I get from doing this is when you succeed. After you've done this, you pass the CCNA, send me an email, let me know that you've got it, and really, I'll be super happy for you. So I really want to help you get there. So a way that we can help keep you on track is with this study plan. So you see I've got it open here, and on this page, it's a breakdown of all of the lectures, all the sections that make up the course, and I've put them into a sample timetable, which gives you an idea of how long it will take to get to your exam date. So you can use my one here if you want. If you follow this one, it's quite intensive. It'll take you maybe a couple of hours a night, something like that, and then it'll take you about 6 weeks to get your CCNA. So you can see it's a lot of work, but if it wasn't a lot of work, it wouldn't really have any value to it. But you doing this work and getting it, that's how you're proving your value to employers, and that's how you're going to really build your career. So this is if you want to do it over 6 weeks. But what to do is, you see I've got the next couple of pages are blank. So you
Alright, so Mr. I want him to. So I'm a CCNA guru now. So what I want you to do is, yeah,
can fill your own time here. You see I've got the next couple
Watch section 1 and 2 55-minute install packet tracer. Okay, today we are going to watch section 1 and section 2. We already installed packet tracer, so it's not a big deal. Section 3 and 4 are lab complete exercise. Might do day 1 and day 2 today, so if you are with me, please follow along. I hope you are following along with me, and I hope we can pass CCNA together. And yeah, so let's get.
Pages are blank, so you can fill your own timetable in here based on my template. Now,
How
don't fill
many
it
weeks did you said? Week
all
7.
in right at the start, because for sure.
So I'm not going crazy today. Jeez, that smells nice. Earlier I went to a perfume shop, so that smells nice. Anyway, what is up, chat? What is up? What is up, chat? What is up, chat? What is up, chat? Chat. I want to. Let me take one TikTok. Post it on TikTok. If you guys are on TikTok, don't follow me. It's really embarrassing. So, yo, learning a little bit of streaming. Um, Streaming is definitely learning. And that's the camera, and that's me. Okay. Peace out. Streaming is definitely learning. That's the camera, and that's me. Peace out. Okay, CCNA STREAM stream. Okay, post. Well, I am happy that this streaming setup looks really good.
Some things will come up and it might knock you back a few days. So what I suggest is fill in 1 week at a time, make it quite hard to do it, but doable, and then try to do it. And then at the start of the next week, see where you are and fill in your planned timetable for that week. And really, it's going to help you get your CCNA quicker. Things will come up, like maybe it's your friend's birthday. If it's your friend's birthday, skip that day. Life's too short. Some things are more important. But this will help you minimize those skip days and get your CCNA.
Yeah, he's right. Tomorrow, my friend has invited me, and his birthday is tomorrow. That is why I'm trying to finish 2 days today. 2 days today.
As quickly as possible. Okay, you can download it in the extra material for this
You know
lecture.
what? When you know nobody's watching you, even though I'm streaming to the whole world, and I know nobody's watching me, that feels really, all the time. All those time that I thought getting in front of camera is shy, a little bit. I'm shy in getting in front of camera, and I don't even know who is watching. No, I don't feel any shy today.
This is a
And one thing about it is, if you don't have a subscription for Udemy, you can watch mine. Or you can watch my stream and learn from here.
short updated video about the new Udemy interface where I'll cover some things that might not be immediately obvious. First thing to tell you about is the review system, because you should be getting a prompt to leave a review for the course very soon. And the way that the review system works, as you can see here, is that courses which get an average rating of less than 4.1 can actually...
Okay, 2x speed is too much.
be removed from the system. So the way that the review system does work is that a 5 is a pass and a 4 is a fail. It's kind of crazy. Now, obviously, I'm not going to tell you what review score to leave for me. Please leave whatever you think.
His accent and the speed that would, I think even the English speaking person, they would have a hard time to understand this. Am I right, chat?
Think it's fair, but do realize that I really do care about getting you through the CCNA and making this course as high quality as possible. If you do have any issues with the course, then please send me a private message to let me know, and I promise I'll do my best to fix that for you. Okay, moving on to the actual interface. So you can see that when you go into the course, you'll land on the overview tab here by default. Over on the right hand side, you can scroll through all the contents of the course. It's laid out by section. And this check mark here says that the video has been completed. So when you finish the course, to get your certificate, make sure that you do have a checkbox in all of these to show that you have completed the course. Other things to show you in here. When you play the video, an important thing is on the settings button here. If the video appears blurry, it's not a problem with the video, it's actually a problem with the network connection on your side. And what's happening is Udemy is downspeeding the video because of your network problem. What you can do to fix it is come in here and set a fixed resolution here. So sometimes even if there's not actually a problem on your side of the network, that issue can occur. Easy way to fix it. If you do see the video is blurry, just come in here and set a fixed resolution and that should fix it for you. Another thing in here is over on the left here, you can set the playback speed. So if you want to play the videos a bit faster, you could put it to 1.25 or 1.5 is a good suggestion here. If you find my Scottish accent a little fast, you can also set it to slower here as well. Another useful button is if you missed something that I just said, you can click the button here to rewind slide. In this lecture, you're going to learn why passing the Cisco CCNA is such a great choice for your career. So I'm here on Monster, which is one of the biggest job sites in the UK where I'm from, and I'm going to plug in all of the other best known entry and mid-level IT qualifications that you could study for. So let's start with Microsoft MCSA, and I'm going to see how many job results we're going to get for it. Okay, if you're qualified as an MCSA, there are 143 job vacancies waiting for you today on Monster. That's for Microsoft Windows if you want to go into the server team. Maybe you're not so interested in Windows. Let's have a look at Linux and the Red Hat Certified Systems Administrator. So there's about 150 jobs for Microsoft MCSA. For Red Hat, there's only 21 jobs. Okay, let's try other Linux. There's the Linux Professional Institute, LPI. They do qualifications as well, which are popular. Only 12 jobs for LPI. Okay, maybe Linux isn't such a good idea. How about VMware, virtualization in the data center? The main qualification for that is VCP, and there are 111 VCP jobs currently on the Monster website. Let me go down the list. So maybe we don't want to work in the server or the data center server team. Let's have a look at the other networking qualifications. We'll start off with CompTIA Network Plus, well known and popular. How many jobs have we got for that? We've got 72. Maybe we don't want to do a vendor neutral CompTIA qualification. Maybe we want to do the Juniper qualification. The JNCIA is their equivalent to the CCNA. We've got 40 jobs for that. So all of these jobs are coming in at around maybe 50 or 100 vacancies right now. Maybe we are not going to do server team or networking. Maybe we want to be on security. Security is meant to be hot this year. So let's have a search for CompTIA security. And if you've got the Security Plus qualification, there's 179 jobs waiting for you. That's a little bit higher, a little bit better, still under 200. Another well-known security qualification is CEH, the Certified Ethical Hacker, and CEH is way down at 22 jobs again. Okay, so all of the other entry or mid-level popular qualifications that I could think of are coming in at under 200 vacancies today. Most of them are around 50, a few of them are up around 150. Okay, let's have a look for the Cisco CCNA then, see if it's any better. Okay, 513 jobs waiting for you once you've got the Cisco CCNA qualification. So you can see from that the Cisco, the CCNA, it's killing all of the other qualifications out there. This is the best qualification to do if you want to break into an IT role. So I'm really glad to have you on the course. I'm really happy that I'm going to help you pass this qualification. It's going to make a huge difference to your career and your life.
It's gonna make my life a huge difference. I guess so.
I'm recording this on the day that the CCNA version 1.1 exam went live, and it's just a super quick video to let you know, in case you were worrying about it, that yes, this course is fully up to date for the current version 1.1 of the exam. This course is actually always up to date. Whenever Cisco are planning to release a new version, they release details of that a few months ahead of time, which gives me plenty of time to have the course up to date anytime a new version is coming out. So you never need to buy another CCNA course. This course is always going to be up to date for whatever the current version of the exam is. Okay, that's all I needed to tell you here, so let's get on with the course.
Okay, Neil, I am ready to learn with you.
This course comes with full lab exercises, so you'll get hands-on practice with all of the Cisco technologies that we're
Okay, now she's gone. Let's continue.
we're going to be covering. I use the free software Cisco Packet Tracer for the labs, so there's no need for you to buy any Cisco equipment or any other software. In this section, I'll show you how to set up the lab. In the first video, I'll show you how to install Packet Tracer, and then in the next video, I'll show you where to find the lab exercises in the course, how to download them, how to load them up in Packet Tracer, and how to use them. The course also includes flashcards to test yourself on and help you better remember all. In this lecture, you'll learn how to install Cisco Packet Tracer, which is the software used to run the lab exercises in the course. You don't
I have already downloaded, so I don't have to do this. Uh, Next, please.
In the last lecture, I showed you how to install Cisco Packet Tracer, so hopefully you've got that done already. In this lecture, I'll show you how to use the lab exercises that are included in the course. First thing to tell you is where to actually find the lab exercises. So as you can see here, I am logged into the course. And to get the lab exercises, they're included at the end of all of the technology sections. The first lab exercise is at the end of section 4. So if you see there, the section 4 is the Cisco iOS operating system. And if I expand down that section, you can see that the last lecture is the iOS operating system lab exercises. And if I click on that and scroll down a little bit here in the main window, you can see I've got a link there to download a zip file. So I'll do that now. So I'll click on the zip file and download it. Okay, while that is downloading, let me show you where the other lab exercises are. So the first few sections, a lot of them do not have lab exercises. And the reason for that is that I cover the foundational information in the first few sections. I need to do that to lay the groundwork for learning the technologies that are going to be covered later in the course. So those first sections that are covering the foundational knowledge, there's no actual hands-on component to them, so there's no lab exercise. It wouldn't be relevant to have a lab exercise in those sections. So out of the first few sections, the first section that does have a lab exercise is section 4, the one that I just downloaded. The next one after that is section 11, Cisco device functions. So if I look at section 10, for example, and expand that out, you'll see there's not a lab exercise at the end of that section because it wouldn't be relevant there. But from section 11, if I expand that out, again, you can see at the end of the section, there's a lab exercise there. You can click on it. And again, in the main window here, if I scroll down, you see that there's a zip file to download the lab exercise. And every section after section 11, you're going to find a lab exercise there. So what to do is you're going through the course, just go through the course from start to finish, watch your videos, and then at the end of each section that's got a lab exercise, do that lab exercise before moving on to the next section. Okay, so I've got that lab exercise downloaded now. They're really small, so it should only just take a few seconds to download. Let me have a look at that. And you'll see that it is a zip file. So if I open up this zip file and drag it over to my main window here, you see the first lab exercise, there's just 2 files there, which is the packet file, which will open in Packet Tracer, and there's also the lab exercise PDF, which is the instructions to do the lab exercise. So let's open the project first. I'll double click on the packet file, and that's going to open it up in Packet Tracer. Now, when you open Packet Tracer, if you haven't opened it for a little while, it's going to ask you for your login details, and you can see it's going to do that for me here. So I will enter the email address that I used when I installed Packet Tracer. And then on the next page, it's going to ask me for my password as well. So I'll enter that and then I can sign in. When I click on sign in, it's going to open up Packet Tracer and it's going to open up the project. Now this first project is just a walkthrough of the basic commands in iOS. So I've just got one router there. And if I go back to the zip file and if I'm going to open up the lab exercise PDF, inside the lab exercise PDF, I'll drag that over to my main window here as well. It's going to give you instructions in here, step-by-step instructions of what to do the lab. Now, the first couple of lab exercises, I tell you the commands to use because the first couple of lab exercises are guided walkthroughs. In the later lab exercises, you're going to see that I don't tell you the commands to do because you'll have learned them already in the videos that you watched in that section. So when you do the lab exercise, it's going to be up to you to remember what the commands are. I'll show you that in a bit more detail in a second, actually. Okay, so I've got the step-by-step instructions here. I'm just going to follow the...
So he's going to do the lecture, do all the learning stuff first, then go through the lab exercise. And in lab exercise, he's not going to do what are the commands. That is helpful. We'll have to learn ourselves. Okay.
The step-by-step instructions. As I follow them, to access the router, just click on the router that the lab exercise tells you to configure. And then in here, click on the CLI tab, and that will bring you to the command line interface. I'll hit enter in here. That gets me into the command line. I could then click enter enable to get to the enable prompt, and then config T to configure the terminal. Okay, so that's how you access the lab exercises. Just download the zip file, then open up the packet tracer file, and then follow the instructions in the lab exercise PDF. So you saw there that the first couple of lab exercises just have the packet tracer file and the lab exercise PDF because they're guided walkthroughs. But if I go back onto the course again, and I will download one of the other lab exercises here. So I'm just choosing one here at random. So this is the router and switch basics. I will download the zip file here as well, and then open it from my downloads folder. And you're going to see here that all the lab exercises after the first two are going to have more files in the zip file. What you'll find in there.
In next video, so live streamer, so I am going to use this one. This is multi-ISO. I've got a bunch of ISO file. If you don't know what ISO file is, ISO basically is a exe file for operating system. So you cannot directly install exe file on the hardware, right? Exe files, those are only for the Windows operating system. So you install Windows and then you install exe file. But how do you install Windows on the actual hardware? So that's where the ISO files comes in. You can use Linux, Windows. Honestly, I haven't tried. Alright, she's gonna cook for me. Nice, Tina. Anyway, so what I was saying is so you install ISO into an actual hardware, not on the operating system. So that is hypervisor, virtualizer. The virtualization hypervisor is another lesson, another topic that one day I want to talk with you. It is really interesting, really interesting. Today, let's just stick with the CCNA.
Is starting off at the top, the startup configurations. So if you're interested in quickly seeing the configuration that has already been applied to the routers and switches at the start of the lab, you'll find them in the basic configs here. So there you go, you see you'll find those as text files. Then there is the lab exercise and the answer key. So in these later lab exercises, the lab exercise PDF does not tell you the commands to enter. You should have learned them earlier in the section. So it's going to be up to you to configure the tasks in that lab exercise. Now, if you get stuck or if you want to check your work, I do also have the answer key there as well. The answer key tells you all the commands, everything that you should have done to complete that lab exercise successfully. So when you're doing any of the lab exercises, if you get stuck at all, if you're not sure of anything, just look in the answer key. It's going to tell you everything that you should have configured there. There is also the packet file again to open it.
I think I have Anki as well.
In this lecture, you'll learn how to use the Anki flashcards, which are included
Yeah, I
in
have
the course.
Anki.
The point of the flashcards is to test your understanding and memory of all the topics that we are going to be learning about in the course. We use Anki software for the flashcards. That is
Yeah.
spaced repetition software, and what it is designed to do is to make sure that you've got good understanding and memory of all the topics of the course and that you develop that as quickly as possible. The way it works is you will see a flashcard with a question on one side of the card, and then if you answer that question correctly, then you're not going to see that card again for a little while. However, if you're not able to answer it correctly, then you're going to see that card more frequently.
I don't know how to use Anki. Hey guys, it's really simple. You can just download Anki and import a flashcard to it. And one thing is you might want to change. Yeah, so options. You might want to change. Usually it comes only with 220, and you cannot do more than 20 flashcard a day. So you might want to increase. And if you increase this one, this will have to also be increased. This will have to be increased as well. Jesus fucking English. Um, yeah. So when you reset it, it's gonna turn. Fuck my mouse. Uh, is still set into default value? Yes. Uh, okay. See, that's what I told. It's gonna be 20, and you might want to change it. You can't do more than 30 a day. It's otherwise it's gonna fry your brain. So let's do 30. When you increase this one, this will also have to be increased. See, so it says 300. So I'm gonna do 500 just to be sure and save. That's one thing I struggle at very first. I had to go multiple blogs and tutorials. Nobody said about that one. I had to figure that out on my own. Yeah, best of luck.
In this section, you'll learn.
So host-to-host communication. Host-to-host communication. So we just did one thing, connecting this laptop to this laptop, right? There is a connection. How did that connect? There are few different ways: inscription and description, de-inscriptions. Uh, Lots of things happening, but basically they are communicating. That communication is called host-to-host communication. As far as I remember, that is what the host-to-host communication was. And let's see.
About the OSI reference model. The OSI model is a conceptual framework that helps lay out how computer networking protocols should
Okay.
work.
Let's recall what OSI models, layer of OSI models are. Um, Application layer first, and it is application also. Let's just so OSI model, it goes backward. So instead of 1 2 3 4 5 6 7, it goes from 7 6 5 4 3 2 1. So no, it doesn't go sideways, it goes ups and down. So it goes 1 2 3 4 5 6 7, and each layer does different ways. Each layer function differently, but they have some of the layer have a similar functionalities. So later on, TCP/IP model has combined few of the layers, but still till the day when you are working in a network, OSI model are still referenced, and that's why you want to learn about OSI model. So physical layer means you can touch, that's the physical things, that's a physical layer. And after that, it's all about non-physical. Physical, data link, transport, internet, no, transport network. Uh, yeah, physical data link transport network. That's for network. And presentation. No, I forgot the fifth, but 6 and 7 is session. No, fifth is session, sixth is presentation, and seventh is application. Let's go. Did I say it right? Yeah, physical data link network transport. Oh, I think I switched this one, right? No, I think I did it right. Session, presentation, application. Physical layer, the one I can touch. Data link, that's connect to the physical layer. Yeah, I was wrong on that. Network layer, definitely you can understand network. It's transferring. Transport layer, it's what is taking those packets. Session layer, it's I the way I remember this session layer is whenever someone, so if I log in into an application, right? So that's where the session start. That's and if I log out, that's where the session finish. And that's how I remember a session layer. And there is in cybersecurity there is I think one of the attack is called session hijack. Basically even though you are not in that application, even though you are not in same network, once you log in and they have certain things, certain criteria is met, they can log in into anywhere. Um, anyway, so let's see.
Work with each other. And it really helps aid your understanding as you're learning about networking as well. Actually, this is going to form the bedrock of your understanding of networking, so it's a really important section. We'll also go into the definitions of the different layers that make up the OSI model before covering them in much more detail in later sections throughout the course. We'll also cover the TCP/IP suite and discuss how it relates to the different layers of the OSI model. In this lesson, I'm going to give you a very basic introduction to networking. If you already know about switches and routers and network topology, you can just skip right on ahead to the next lesson. But if you're brand new to networking, then I'm going to give you a quick overview here. So let's say that we've got an office which is in New York for our company. In that office, I'm going to have end hosts like PCs, a server, and a printer, like you can see here, and they're going to need to be able to communicate with each other. So for that, I'm going to put in a network switch, and I'm going to cable my devices to that switch with Ethernet cables. And that's what a switch looks like. There's a Cisco switch. You can see it's got a lot of ports in there so that I'm going to be able to connect in a lot of devices. The switch is what allows connectivity on my local.
Switch is a bitch. Very smart bitch. No, hub is definitely a bitch. That's dumb bitch.
Local area network. In that office in New York, maybe I've also got a laptop, which is going to connect in over a wireless network. So for that, I'm also going to have a wireless access point, which is also going to connect into our switch. And that's what a wireless access point looks like. So I've got all my devices in New York now. They can all talk to each other. I've built a local area network. A local area network is a network that connects devices which are in the same local area, like in a single office or maybe a university campus. Okay, I don't just want my end hosts in my office to be able to talk to each other. They're going to want to communicate with other devices out on the internet as well. So for connectivity out there, I'm going to need a bit more of an advanced device, which is a router. A router is able to make advanced routing decisions to route traffic between different areas of your network. That's why it's called a router. And this is what a router looks like. You can see it's pretty similar to a switch, same kind of size. Typically, it will have less physical ports on there, and it will support different types of ports so that it can connect different types of networks as well. Next thing, we know that there's going to be bad guys out on the internet, hackers who are going to try to attack us, so we need to guard against that, so we're going to put a firewall in place. And this is what a firewall looks like. Again, you'll see that our different network devices tend to look very similar to each other, but they fulfill different tasks on the network. The firewall secures the different parts of our network from each other. Okay, so that was our New York office, the local area network, and its connectivity out to the internet. In a larger company, we're not going to just have one office in New York. In our example here, let's say we've also got an office in Boston as well. In Boston, we're going to have a similar kind of setup, the same kind of devices in there. We're going to have the local area network in Boston, and we've also got local connectivity to the internet from Boston as well. Now, because we're the same company, I'm going to want to have connectivity between my New York and my Boston offices. I want the end hosts in both of those sites to be able to communicate with each other.
All right, check. One thing about these things, right? These are obviously it's when you are working in IT, you have to know a lot of things, and in reliability, scalability, availability, and security. These four of these you have to have understand that you have to manage this when you are working when you are in for example you have seen in a football, right? Defense, offense, they're playing things. There's a chart that goes ups and downs. For example, there's a pentagon, and the points goes more, some goes higher for some people, some goes lower for the charts. So you have to arrange these five for those as well. Security, reliability, availability. For example, the system is secure. Why is it secure? Because nobody can access it. But you want to give access to some people. Giving access to some people may invite the bad guy as well, and that's not secure. So not allowing, that's where the firewall comes in. That is just one example. That's where the firewall comes in for external people. And even inside the organization, giving access to certain team, giving not access to certain teams, that's where the permissions and all those comes in.
Other. It is possible that they could communicate securely over the internet if I set that up, but another way of doing it is I could maybe put in a dedicated connection between my two routers in both sites, and that's going to give me my wide area network connection between my different offices. Okay, so that's a really quick overview of networking, and the point of networking is to allow that connectivity between our different end hosts on the network. So looking now at the characteristics of a network, we've got the topology. If I just go back to that previous slide, this is an example of a network topology diagram. The topology is how the devices are connected up to each other. Other characteristics is the speed of the network. Typically, the faster the network is, the more it's going to cost you, and cost is itself a characteristic as well. Things that will affect the cost are the type of devices you have in there, the size of the network, the different technologies you're using, etc.
And cost. Cost is a huge thing, man. Huge things. Definitely, if you are getting something, companies, it's gonna cost company. But you don't hear a lot of cost things if you are in a big company, but small to medium sized company cost, you will hear a lot about cost.
Other characteristics are security. I mentioned the firewall in the previous slide. We're not going to just have security on our firewall though. We'll also have security features on our routers and on our switches, and we can have other security devices such as intrusion prevention systems as well. Next, we have availability. We're going to want to make sure that our network always stays up. And for mission critical components in the network.
Now I want to show you one thing about this my home lab. So 192.168.1 dot. Okay, that didn't work. 44. I think there's a port number as well. I think the home lab is down at the moment. See, some system has to be up for a long time. I'll show you later on.
Work. Typically, we don't want any single points of failure, so we will double up on those components so that if any one fails, we've got an alternative component that will still be up and running. Scalability is also important. We want to design the network in such a way that it's easy for it to grow with our company without requiring a redesign. And reliability, similar to availability, where we want to make sure, again, in this lesson, you'll learn about the OSI model. The Open Systems Interconnect model is a standard of the International Organization for Standardization. So it's an ISO standard. It's a general purpose framework that characterizes and standardizes how computers communicate with one another over a network. So the OSI model, it's conceptual. It's not a physical thing or an actual protocol or technology. Its 7-layer approach to data transmission divides the operations into specific related groups of actions at each individual layer. And a layer serves the layer above it and is served by the layer below it. Now, I know that doesn't make much sense yet, so let's have a look at how this works in action. So let's look at an example. Here I've got a sender on the left, let's say that's my laptop, and we've got a receiver on the right, let's say that's my email server, and we're both connected into a switch. And I'm going to send an email to my email server. So obviously the sender is going to compose this traffic that's going to be sent to the receiver. And as it builds this packet that is going to be sent, it's going to start off at the top level and then it's going to work its way down to the bottom level. So at the sender, first off, it will create the layer 7 information, which is the application layer. So if I'm sending an email, that will contain information such as the from and the to field, etc. Then it will encapsulate the layer 7 information in the layer 6 information. Layer 6 is the presentation layer. And then it will encapsulate that in the layer 5 session layer.
So he says encapsulate, right? But he didn't explain what is encapsulate. Just think it as zipping a file. So when you zip a file, right, you close it into a zip folder, and which will reduce the file and also make it a bit secure than just open file. That is what encapsulation is. So imagine that application layer zipped one of his data and gave it to a presentation layer, and presentation layer will add his more data on top of that, and he will zip again. So that's one file from presentation. Again he will send it to session layer. So session layer will add more data and again combine, zip it. Session layer will send to another layer, add more data and zip it. So once that is sent to number 1 from 7 to 1, it's going to be a chunk of file. It has more data, more metadata, and more information, and that is sent to another device, right? So another device is going to open one file, read the file, and he will decide, oh, this is about this. This is going to this place. This is going to this place. Oh, this is this kind of file, so I'm going to reject it. I'm looking for this kind of file. I'm going to reject it. This is not for me. This is how, like, de-encapsulation. Again, if when they find this file is for me, so they open it. Oh, this file is for me, so I'm going to send it to this. Okay, the upper layer says, oh, this file is for me. I'm going to send it to this. I'm going to send it to this, or I'm going to reject it. And that's where the IP address comes in. That's where the MAC address comes in. That's where a lot of prefix and data, packets, all those words comes in.
Information. Layers 5, 6, and 7 are known as the upper layers, and they are more important for application developers rather than network engineers. Network engineers start to get really interested when we get down to layer 4. So we've got our upper layer traffic composed. That then gets encapsulated with our layer 4 header, which is the transport layer. At layer 4, this is going to be either TCP or UDP, and it will include the port number, such as port 80 if it's web traffic, port 25 for our email example. Now, if you don't already know the details of TCP, UDP, and port numbers, don't worry about it yet. We're going to cover all this information in much greater detail in later lessons and actually throughout the entire course. Okay, next thing that happens is that will then be encapsulated with our layer 3 header. Layer 3 is the network layer. And important information that is included there is the source and destination IP address. A network device that operates at layer 3 is our routers. The next thing that will happen as we compose the packet is the sender will then encapsulate that information in the layer 2 header. Layer 2 is the data link layer. And important information there is the MAC address if we're sending this over an Ethernet network. The network device that works at layer 2 is our switch. And finally, this packet is now ready that we can actually transmit it over the wire. When we do that, we're down to layer 1, which is the physical layer. A network device, which you don't really see anymore, which operated at layer 1 was hubs. So we've now composed the packet at the sender side, we've put it onto the wire, it's going to travel over the network, and it's going to reach our receiver. the order of operations is going to be reversed now, because obviously it comes in at the physical layer. The receiver will process the packet from the bottom layer back up to the top layer now. So it comes in at the physical layer. The receiver will then look at the outside header, which is the layer 2 header, and it will check that this packet is for it. It will check that the destination MAC address in the layer 2 header is its MAC address. If it's not for it, it will just discard the packet. Next up, it will continue with de-encapsulation now. It will then look at the layer 3 header. It will check the destination IP address, and again, it will check that the packet is for it. If not, it will discard the packet. Then we carry on with our de-encapsulation on the receiver. It will look at the layer 4 header. What this is useful for is, imagine the receiver is not just an email server listening on port 25 for email traffic. Let's say it's also a web server as well, listening on port 80 for web traffic. Well, how does it know if this traffic is for its email server application or its web server application? It can tell by looking at the port number. Next, we'll carry on with the de-encapsulation. We'll strip off the layer 4 header. We'll look at the layer 5 header at the session layer. We'll carry on up. We'll then look at the layer 6 header and then the layer 7 header. So that's the whole thing. That's how we got traffic from the sender to the receiver as far as the OSI model is concerned. At the sender side, again, we start off at the top layer. We work our way down to the physical layer. It goes across the physical layer. It will hit the receiver there, and it will then de-encapsulate going in the opposite direction, going from the bottom layer up to the top layer. Looking at the benefits we get from the OSI model, engineers don't need to design a technology to work end-to-end from top to bottom of the model. They can just focus on their layer of expertise and make sure that they comply with the standards for the layers above and below. This leads to open standards and multi-vendor interoperability. For example, if you're an application developer, you can just focus on the top 3 layers. The lower layers are the domain of network engineers, so you don't need to understand them. You just need to make sure that where you interface between layer 5 and layer 4, you're complying with the standards there. Troubleshooting.
I missed something.
Top 3 layers. The lower layers, application developers and multi-vendor layers of their layer of X and engineers. Looking at the benefits we get from the OSI model, engineers don't need to design a technology to work end-to-end from top to bottom of the model. They can just focus on their layer of expertise and make sure that they comply with the standards for the layers above and below. This leads to open standards and multi-vendor interoperability. For example, if you're an application developer, you can just focus on the top 3 layers. The lower layers are the domain of network engineers, so you don't need to understand them. You just need to make sure that where you interface between layer 5 and layer 4, you're complying with the standards there. Troubleshooting is also easier because you can analyze a problem in a logical fashion layer by layer. It's difficult to overstate just how important the OSI model is to computer networking. As you become more experienced with networking, you'll think according to the OSI model when you're troubleshooting or learning a new network technology. This will be natural for you. This is what I do really every day on a day-to-day basis. And on the job, you'll hear technologies and problems being described according to their OSI layer. For example, if you're troubleshooting a problem and you start looking at it in an overly complicated way, it might turn out that it was just because the cable was unplugged. And you would say to the guy next to you, oh yeah, it was a layer 1 problem. You might also hear of a layer 8 problem. That's when a user has made a mistake. Okay, this is going to be tested heavily on the exam, and like I just said in the last slide, it's really important anyway, not just for exam purposes. For your whole understanding of networking, you really need to know the OSI model. It's going to help you. So we are going to have acronyms that are going to help us remember what the actual names of the different layers are. The classic acronym that you'll see in all the books going back years and years is please do not throw sausage pizza away. So again, the layers were the physical layer, then the...
Now this make me hungry. Now you understand why the higher you go, the IT people, they get fat bellies.
Data link, then the network, then the transport, the session, the presentation, and the application layer. When you're first beginning, in fact, to be honest with you, I still remember it from the acronym, and it's just automatic for me. I know it's please do not throw sausage pizza away, and that helps me easily remember what the names of the different layers are and what order they come in. Other acronyms you can use if you don't like that one that's relevant to networking is please don't need those stupid packets anyway. Another one that would be relevant to us here is please do not teach students pointless acronyms.
Please do not teach pointless acronym to student. Please do not teach student pointless acronyms. Please do not teach students pointless acronyms. Please do not throw away sausage pizza. English, man, English. Why?
And a useful one, please do not take salespeople's advice. If you've been working in networking for any time already, you'll know that's great advice. And my personal favourite, please do not touch Superman's private area. Okay, I think enough said about that.
Please do not touch Superman's private area. I don't need those acronyms. I just remember as it is. Application presentation session, uh, transport network, uh, transport network, data link physical. I believe that's the right one, right? Application presentation session, and we said transport. Transport, yes. UDP, TCP, UDP, network, and data link and physical. I mean, so later on, this all of these three will be combined to one application layer. Transport will be it's same. Transport won't be changed. It will be just transport. Network and data link will be combined, and it will be say no. All three will be combined. Transport will be same, network will be same, and data and physical will be combined because those three are very like Neil said. Um, Developer, application developer, they only works with these three sessions. And transport and network, uh, those are network engineers and system administrator or cybersecurity people. And data link and physical, they are the manufacturer people. They look after the standards, you know. For USB-C, there are hundred. I don't know how many, but there are multiple spender, multiple suppliers, manufacturer of USB-C. But all the USBs fit in the same port, right? And ports, the company who make like, computers, smartphones, they have USB-C. They have same USB-C ports because that's the standard. They have to keep that in mind. So, yep. Manufacturer, networking people, and software people, or user, or dumb user. That's how you remember. Application presentation session, transport, network, data link, and physical layer. Um, like I said, I remember first three, and then transport and network. I always get confused which come first and which come not, which come last. But I just thought of one thing: TCP, UDP, and ports. Just relate that to a physical layer that comes first, and then inside that's a network. Once the physical are connected, then the network. So application presentation session, transport. Oh no, net. Fuck. Transport, network, data link, and physical. Yeah, fucking dumb acronym. I don't remember.
In this
Hello.
this lesson, you'll learn about the TCP/IP suite. TCP/IP was developed way back in the 1960s by the US Department of Defense's Advanced Research Projects Agency, that's DARPA. It's a protocol stack which consists of multiple protocols, including TCP, which is the Transmission Control Protocol, and IP, which is the Internet Protocol. So it's not a single protocol, it's a protocol stack. What a protocol is, if you think of diplomats, when diplomats from different countries meet each other, there's a certain way that they're expected to behave and to communicate with each other. In computer networking, protocols basically mean the same thing. So if you've got two hosts and they're going to communicate with each other, there's going to be a protocol which is going to control how that communication should behave and how it should work. TCP/IP, it's the main protocol stack used in computer operations today. There used to be other competing protocols way back in the day, like IPX, SPX, and AppleTalk, but they're really dead now. TCP/IP is now ubiquitous. And whereas the OSI reference model is conceptual, The TCP/IP stack is actually used to transfer data in today's production networks. TCP/IP is also layered, but it doesn't use all of the OSI layers, though the layers are equivalent in operation and function. So it does actually use them, but in the documentation, it only lays out 4 different layers. Let's look at those now. So you can see on the slide here, over on the left, we've got the OSI model that we covered in the last lesson. So we've got the 7 layers there. Remember, easy way is please do not throw sausage pizza away. So we've got physical, data link, network, transport, session, presentation, and application. Over on the right, we've got the TCP/IP stack. So you can see we've only got 4 different layers there. Up at the top, we've got the application layer, which maps to all 3 of the application, presentation, and session layers in the OSI model. Below that, we've got the transport layer, which is a one-to-one mapping with the transport layer also in the OSI model. Underneath that, we've got the internet layer, which is equivalent to the network layer in the OSI model. And down at the bottom, we've got the link layer, which maps to the data link layer and the physical layer in the OSI model. Now, I was saying in the last lesson, it's really important to understand the
I have to get a new mouse, man. Fucking this one is shit. So this one is for the users, developer, all the application you see in the front. Takes logs, takes information about the software and data, all the human readable language. Transport, they are the network readable language. Um, let's say these are the protocols, routing protocol, OSPF, ports, which ports are you connecting, in which routing protocols are you using, in which um, connection are you using to connect to the devices? Okay, network layers, this is where IP address is. This is where the metadata of the packets is. This is the main juice, I believe. IP addresses provide logical addresses and determine the best path through the network. Okay, so that's where the I think that's where transport. Okay, I'm a bit confused about transport and network. I have to learn more about this too. Let's see. Don't save.
The OSI model. The TCP/IP stack, for sure, if you're working in networking, you're going to know the different protocols like TCP and IP like the back of your hand. But when we're talking to other network engineers, it's more commonly the OSI model that we're going to be referencing. Moving on, looking at some host communications terminology. So when two hosts talk to each other, they're going to be exchanging PDUs, protocol data units. The PDU is the entire communication all the way from layer 7 down to layer 1 of the OSI stack. We can also divide that into different terms depending on which layer of the TCP/IP suite we're talking about. For communications up at the application layer, that's called data. For communications between the transport layer on two different hosts, that's called segments. Between the internet layer, those are our packets. And down at the link layer, those are our frames. So you noticed on the last slide, I was saying typically real world, we're not going to be discussing the TCP/IP stack like this about the 4 layers. More commonly, we'll use the OSI 7 layers. But on this slide, the terminology actually is commonly used. So if I'm talking about layer 2 communications, I'll call that a frame. If I'm talking about layer 3, I'll call it a packet. And if I'm talking about layer 4, I will call it a segment. Another thing I need to tell you here is that packet officially is at layer 3, but you might have heard me talking earlier on in this section and calling the communication between two hosts a packet. So really the correct term is a PDU, but in day-to-day conversation, often we'll just call communications between two hosts a packet, meaning the entire stack. In this lecture, you'll learn about the upper layers of the OSI model. That's the upper 3 layers, 5, 6, and 7. Network engineers don't typically work directly with those upper 3 layers of the OSI model. They're more relevant to application developers.
Okay, yeah. Oh, man.
And for the exam, we need to know the definitions of each of the layers as well. It's quite likely that you'll be tested on that. So in this lecture, that's primarily what I'm going to be doing, is giving you the Cisco definitions so you'll be ready for the exam. Information included in the upper layers would include the message body and the subject line in an email message, for example. So let's look at the 3 top layers, starting with layer 7, the application layer. This provides network services to the applications of the end user. It differs from the other layers in that it does not provide services to any other OSI layer. The application layer establishes the availability of intended communication partners. Intended communication partners would be the host that this host is communicating with. If you remember from the lecture before when we were discussing the OSI model, you saw that straight line between two hosts at the same layer of the OSI stack. Okay, so the application layer establishes the availability of intended communications so you'll be ready for the exam. Information included in the upper layers would include the message body and the subject line in an email message, for example. So let's look at the 3 top layers, starting with layer 7, the application layer. This provides network services to the applications of the end user. It differs from the other layers in that it does not provide services to any other OSI layer. The application layer establishes the availability of intended communication partners. Intended communication partners would be the host that this host is communicating with. If you remember from the lecture before when we were discussing the OSI model, you saw that straight line between two hosts at the same layer of the OSI stack. Okay, so the application layer establishes the availability of intended communication partners. That's that straight line going to the other host. It then synchronizes and establishes agreement on procedures for error recovery and control of data integrity. Data integrity means checking that data has not been altered or corrupted in transit. The next layer is layer 6, the presentation layer. This ensures the next layer not being altered or corrupted in transit. Means checking that data has not been altered or corrupted in transit. The next layer is layer 6, the presentation layer. This ensures that the information that is sent at the application layer of one system is readable by the application layer of another system. The presentation layer can translate among multiple data formats using a common format. For example, it might need to do this for computers with different encoding schemes. And the last layer of our upper layers using is readable. The information is layer 6, being altered or corrupted in transit. The next layer is layer 6, the presentation layer. This ensures that the information that is sent at the application layer of one system is readable by the application layer of another system. The presentation layer can translate among multiple data formats using a common format. For example, it might need to do this for computers with different encoding schemes. And the last layer of our upper layers is layer 5, the session layer.
Did you guys get that? What is presentation layer is? Fucking, I didn't get it. It just said. It's like more like a converter.
This establishes, manages, and terminates sessions between two communicating hosts. The session layer also synchronizes dialogue between the presentation layer of the two hosts and manages their data exchange. For example, we might have web servers which have got many users that are using that.
Jesus Christ, it's been more than an hour.
Obviously, the sender is going to compose. And a useful one, please do not take salespeople's advice. If you've been working in networking for any time already, you'll know that's great advice. And my personal favourite, please do not touch Superman's private area. Okay, I think enough said about that.
Please do not touch Superman's private area. I don't need those acronyms. I just remember as it is. Application, presentation, session. Okay, I didn't realize there's a two Michaels too. Audio output capture, audio input capture. I don't think I will need this. Have to I have understand
And a useful one,
private area. Is it working? Have to I have understand. Is it working? Is it working? Is it working? What's up?
And a useful one,
Private area. Yeah, it's time to wait. Is it working? Have to I have understand. Feels like working? Is it working? Is it working? What's up?
and a useful one,
Private area. Yeah, it's time to wait. Is it working? Have to I have understand. Yeah, feels like I'm in a Tenant movie.
at web server. So in that case, we would have multiple incoming sessions. The session layer keeps track of all of those. It also offers efficient data transfer, class of service, which is similar to efficient data transfer, and exception reporting of upper layer problems. Okay, so that's the definitions of the upper layers. We'll go into the definitions of the bottom 4 layers in the next lecture.
Man, if you're just going to read, then it's like a teacher.
In this lecture, you'll learn about the bottom 4 OSI layers. Where network engineers are not typically very concerned with the top 3 layers, we are very concerned with the bottom 4 layers. This is really bread and butter stuff for us. Each of these bottom 4 layers are so important that they're going to have their own dedicated section later on in the course. Here, I'm going to focus on giving you the definitions, which you're going to need to know for the exam. So the first of the bottom 4 layers, we'll start with layer 4, which is the transport layer. The main characteristics of this layer are whether TCP or UDP transport is going to be used and the port number. Now, if you don't know anything about TCP or UDP or port numbers already, don't worry about it too much for now, because we're going to be covering this in the dedicated section for layer 4 later. For now, you just need to know that if we want the communication between the two hosts to be reliable, then we'll use TCP. If speed is more important than reliability, like for voice or video traffic, then we'll use UDP instead. The other main characteristic at this layer is the port number. For example, port number 80 for HTTP web traffic, port number 25 for SMTP email. Now, there is quite a lot of other information also in the layer 4 header, but we'll talk about that when we get to that particular section in the course. The definition for layer 4: the transport layer defines services to segment, transfer, and reassemble the data for individual communications between the end devices. It breaks down large files into smaller segments that are less likely to incur transmission problems. The next layer is layer 3, the network layer. The most important information at the network layer is the source and destination IP address. Again, there's a lot of other information also carried in the layer 3 header, but we'll talk about that when we get to the later section. Routers are layer 3 devices. They operate at layer 3 of the OSI model. And the definition of the network layer: it provides connectivity and path selection between two host systems that may be located on geographically separated networks. The network layer is the layer that manages the connectivity of hosts by providing logical addressing. IP addressing is our logical addressing. Next layer is layer 2, the data link layer. The most important information here is the source and destination layer 2 address. Again, just like with layer 3 and 4, there is other information also included in the layer 2 header. For example, the source and destination MAC address if Ethernet is a layer 2 technology. Different layer 2 technologies use different formats for their addressing. For example, old legacy frame relay uses DLCI or DULCI numbers for the addressing. With Ethernet, which is what is always used on our local area networks, it's the MAC address that is used here. And switches operate at layer 2. Our switches are layer 2 aware devices. The definition for the data link layer: it defines how data is formatted for transmission and how access to the physical media is controlled. It also typically includes error detection and correction to ensure a reliable delivery of the data. And finally, we have layer 1, the physical layer. This concerns literally the physical components of the network, for example, the actual physical cables being used. Definition of a physical layer: it enables bit transmission, the ones and O's, between end devices. It defines specifications needed for activating, maintaining, and deactivating the physical link between end devices. For example, voltage levels, physical data rates, maximum transmission distances, and physical connectors, etc. Okay, so there you have it. That was the quick overview and mainly the definition of the bottom 4 layers. As we go through the rest of the course, we'll be covering those in much more detail.
Okay, in this video, what we are going to talk about, don't know, but thumbnail looks like it. So I can switch from scene 1 to scene 2, but if I do scene 1, that doesn't work. Okay, we capture device. What's wrong with you? Okay, I'll have to add you once again. Video capture device. Video capture device. So that would be my webcam. A bit smaller. Smaller. No, that looks alright, isn't it? Alright, let's get started anyway.
We've covered quite a bit of theory already, so I'm sure that by now you're itching to see how to actually configure our Cisco devices, our routers, and our switches. Now, Cisco do have graphical user interfaces, like web-based interfaces that you can use to configure the devices, but in the real world, everybody uses the command line. Well, experienced engineers use the command line because it's much quicker than using the GUIs. And the operating system that is used on enterprise-grade Cisco devices is iOS. So in this section, you'll learn how to connect to the router or the switch, and then how to make your way around the command line. Just before we get into that, we're going to have one more theory lecture where I'll talk about the different operating systems that are available from Cisco, because there's not just iOS. So we'll do that first, and then we'll get into actually how to connect to the device and how to make your way around the CLI. Let's do that now. In this lecture, you'll learn about the different operating systems that run on Cisco's different router and switch platforms. Now, you don't actually need to know this for the exam. The exam focuses purely on iOS, on Cisco routers and switches. So if you're wondering why am I including this then, the reason is that it's something that you would wonder about anyway, and I want to explain to you that by taking this course and learning how to configure Cisco iOS, it's going to enable you to work on any of the different Cisco routers and switches, because from a management and an administrative point of view, it's pretty much identical no matter which actual operating system you're working on. So I'll start off by giving you a bit of history. Many people think of Cisco as being a routing and switching company, but they actually were just a purely routing company when they started off. And when they did start off, iOS was the original operating system that they used on routers, the same operating system that's used today, although obviously it's gone through quite a few upgrades in the time since Cisco started back in 1984. So they were originally a routing company. To offer switches, that was through an acquisition. They bought Crescendo in 1993, and the Catalyst switch product line came about because of that acquisition. The original operating system on the Catalyst switches was CatOS, but that's been deprecated quite a long time ago now. Cisco firewalls evolved from another acquisition. That was the acquisition of Network Translation back in 1995, and Cisco got their PIX firewall from that, which uses the Finesse operating system. Now, both the Catalyst switches and originally the PIX firewalls, it's now the ASA firewall, were ported over to the iOS operating system over the following years. So Cisco standardized on iOS for all of their network infrastructure devices. There are some other operating systems on some of the newer router and switch platforms though. So iOS runs on the majority of Cisco routers and switches, but some of the newer platforms do have these new operating systems. Let's look at those now. So on the Cisco Nexus and the MDS data center switches, they run on NXOS. On the high-end service provider routers, the NCS and the CRS, and also on the ASR9K and the XR12K routers, they run on iOS XR. And on the ASR1K service provider routers, they run on iOS XE. So you're maybe thinking, oh, well, this is going to make things more difficult if there's all these different operating systems, but really it doesn't, because all of the different Cisco operating systems, they are incredibly similar from the command line point of view. If you know a command in iOS, it's probably going to be exactly the same command on all of the different operating systems as well. As far as administering and managing them, they're all nearly exactly the same. So you're maybe wondering, well, if managing them is exactly the same, why is there the different operating systems? The main reason and where they're different is under the hood. iOS has got a monolithic kernel, meaning that if one process running on the router crashes, it can crash the entire router. The other newer operating systems have got microkernels, and the processes run in separate protected memory address space. So if one of the processes crashes, it shouldn't affect the running on the rest of the system. So these other operating systems are mainly on the higher end routers and switches, but on the enterprise grade routers and switches, they're still running iOS. Now, don't think that iOS is a bad or an unreliable operating system. It's been purpose-built by Cisco, who are the biggest networking company in the world, to run on enterprise-grade routers and switches. So it is very hardened. It's still very, very reliable. In this lecture, you'll learn how to connect to the command line on Cisco routers and switches over the corporate network. Before we get started, I want to make it clear that the way that the lab exercises work in this course is different than connecting to real routers and switches. The lab exercises use the free Cisco Packet Tracer software, which is standalone software that runs on your PC. So when you're doing the lab exercises in the course, you're not connecting to real routers and switches. You can see section 2, how to set up the lab, for step-by-step instructions on how to set up and use Packet Tracer for the course lab exercises. After you've passed your CCNA, you're going to be working as a network engineer on real networks with real routers and switches. So of course, you're going to need to know how to connect to those real routers and switches as well. And that's what we're going to cover here. So when you are connecting to real routers and switches, you're going to use some software on your laptop to do that. And the most commonly used software to use is PuTTY, which is free software. But again, for the lab exercises in this course, you're not using PuTTY, you're not connecting to a real device, you're using Packet Tracer. So for this course, you do not need to install or use PuTTY. Okay, so let's carry on and see how this is going to work. So in your day-to-day tasks as a network engineer, you're not actually going to be physically touching the network devices. What's going to be happening is you're going to be sat at your desk working on your PC, and the device, the router or switch that you're working on, is going to be in another location. It's going to be in a locked cabinet, either in the same office that you're in, or the office could be anywhere in the world. And you're going to be connecting to that device over the network. And I'm going to show you how.
And that switch or router is going to be in a server room. And usually that server room is called a comms room. Communication room, all right, comms room.
To do that now. So for example, let's say that you, working as a network administrator, you are over here on this PC in London, and you're going to be connecting to this router in New York to work on it. So how are you going to do that? Well, you're going to use software on your PC, you're going to open, you're then going to connect to the router over the network all the way over in New York. You'll get to the command line and you'll be able to work on that router. So to get to the command line interface for your day-to-day management of Cisco devices, the protocol that you're going to be using in that software is called Secure Shell, SSH. And you're going to connect to the management IP address of the device. There is also another protocol supported, which is Telnet, but it is very not recommended to use that because it is insecure. So with both SSH and Telnet, they look and work exactly the same way. But the difference is that when you're entering commands in SSH, those commands are encrypted. When you enter commands in Telnet, they're unencrypted. So if anybody is sniffing your traffic over the network, they can see those commands, including your username and password. So Telnet is not used in real networks. It can be handy in a lab environment, but in a real corporate environment, you're going to be using SSH. As well as using SSH, also for security, secure login is going to typically be enforced, meaning that you have to enter a valid username and password. So we've got usernames and passwords to log in our devices. Your company's maybe got 100 different devices. You don't want to have to configure all your administrators' usernames and passwords on all 100 of those devices separately. You want that to be centralized. So what you'll have is a centralized AAA server. That stands for Authentication, Authorization, and Accounting. It's got access to the central database of all your usernames and passwords, saves you having them on each separate device. We're going to be covering SSH and AAA, including how to configure them in later lessons. I'm not going to cover it here because we need to have all the other settings on the device set up already as well. We haven't even configured an IP address yet, so I need to go through all of those other basic settings first. I'll show you how to configure SSH and AAA in later lectures in the course. Okay, but I can show you right now how this is going to actually work. So let's have a look at that. The first thing that we need to do is to actually download and install PuTTY. So to find PuTTY, it's very easy. We can just go to Google, and I'm going to Google for PuTTY download. And then it's this first entry here at putty.org. I will click on that. And then I can see I can download PuTTY here. I will click on the link. And then I'm on a 64.
Yeah, do that in a corporate environment and you will be getting called from cybersecurity. Yeah, never do that.
4-bit Windows machine
of course,
here.
This is just a lab. You don't want to do it. Of course, this is just a lab and you can do it in your home lab or just a lab environment. But in a corporate laptops, you don't want to do it.
So I am going to download the 64-bit Windows file. So I will click on that, and it's very small. I can see that it has downloaded already. So I will go to my downloads folder. I will double click on the PuTTY installer here. So I click next on the welcome screen. I'm happy to install it into program files PuTTY. Click next again. I'll accept all the defaults here and click on install and then click on finish. So that was in program files and PuTTY. So I could create a desktop for it, a shortcut for this on my desktop. I'm just going to run the PuTTY executable file there, and this is what PuTTY looks like. And you can see in here that I've got my different connection types. So for connecting to a Cisco device, you can use Telnet or SSH or Serial, but I'll cover in the next lecture. We don't want to use Telnet because it's insecure. We're going to be using SSH. and I need to enter the IP address or host name of the device I'm connecting to. So my router is at 192.168.1.254. I'll enter that IP address, and then I will click on Open. And because SSH is a secure protocol, it's giving me this warning message here about the exchange algorithm. I just click yes to say that I do want to continue. And then I get another warning message. I click yes on that as well. And I can see that it says up here, who do I want to log in as? Now, I know this is going to look very small for you. So let me also show you how you can customize the PuTTY settings. So I'll click on the PuTTY icon up here in the top left. I right click on there, and then I'm going to go change settings. And you can see you can change things like the colors, the appearance, and so on in here. I'm going to go to appearance, and for the font, I'm going to change that, and I'm going to bring it all the way up to 22 just to make it easier for you to see, and then click on apply. So I'm going to log in as the user I already created on this real router, which was Neil. And then I've also configured a warning message that it's only for authorized users. And then I'll also enter in my password there as well. And you can see I am now connected onto the New York router. So very simple to connect to real Cisco devices over the network. Just download PuTTY, then open PuTTY, enter the IP address of the device that you want to connect to, enter in your username and password. If that has been configured in your corporate network, which it most likely will be, you're now on the command line of the router and you can start configuring it. Okay, one last thing that I want to talk about here, and that is out-of-band management. So let me go back to the slides again. And you saw in that example there that I was the administrator over on the PC here, connecting over the corporate network onto the router in New York. And that traffic was going over the production network. What the production network means is the network that is being used for your normal user traffic, the network that is used for your staff in their normal activities. So, for example, let's say we've got a normal staff member on their laptop here, and they are connecting to an email server, for example, over in New York. Well, when they connect to it, they're connecting over this network path here. That's the production network. And that was the same path that you went over when you were connecting to the router. So you can connect to the router for management over the normal production network. What you'll find most large companies do is they'll also have a separate dedicated network for management as well. So it looks like this. The reason that they put in a separate dedicated management network is maybe there's a problem with the router in New York over the production network, and you're not able to connect to it over there. So by having a separate dedicated management network, that gives you a backup path that you can use to connect to your network devices if they have any problems. It's also more secure having a separate dedicated path as well. So now we've got two paths that we can use to get to our router. When you do have a
And that's that there you call a redundancy as well. If something fails, you have a fallback option. Management network, that's called redundancy.
separate management network set up. If you're connecting over the production network, we call that in-band management. You're going in-band over the production network, going over the same cables that your normal users are using to connect between offices. If you connect over that separate management network, we call that out-of-band management. It's out of band, not over the same path as your normal staff traffic. Okay, so that was everything I needed to show you here about connecting over the network. In the next lecture, I'll show you how you can connect to a router over a direct console connection.
I'm a bit hungry, man.
In the last lecture, I showed you how to connect to a Cisco router or switch over the network. In this lecture, I'll show you how to make a direct connection using a console cable. Before we start, I'll give you a quick reminder that the lab exercises in this course use Cisco Packet Tracer simulation software, and you can see how to install and use that by watching section 2, how to set up the lab. So for the lab exercises we're going to be using in the course, you don't need any physical devices, and you don't need to install or use PuTTY. But when you go and you start working on real devices in the real world, you are going to need to know how to do this, how to make the initial connection to a physical device. So that's why I'm going to show you.
I'm a bit hungry. I'm gonna eat something and I'll come back. All right, time for more learning now.
Here. Cisco devices do not usually have a default IP address, so we need to set one up before we can connect to it over the network. As you saw in the last lecture, I used PuTTY to connect to the management IP address of the device. But what if the device does not have an IP address on it yet? Well, we need a way to connect to the device to do the initial configuration when we first buy it, including adding IP addresses. And that is where the console connection comes in. So with the console connection, we can directly connect to the device at a lower level below IP, get onto the command line there, then we can get to do the initial configuration, including adding the IP address, and once we've done that, we'll then be able to connect to it over the network. So for that initial direct connection, you connect to the
That is called rollover cable, I think.
console port on the router or switch. I'll show you that in a second. And you use a console cable to do it, which comes in the box with your device. And the console cable looks like this. You can see that it has got a serial DB9 connector on one end. It's called DB9 because 9 pins go in here. And on the other side, it's got an RJ45 connector, similar to what you would see on a standard Ethernet cable. But this is absolutely not an Ethernet cable. It's not using Ethernet and it doesn't require IP addresses. This gives you a low-level direct access to the command line. Now, when you connect this into your router or switch, it's the RJ45 end that plugs into the console port on the device, and it is the serial connector that plugs into your laptop. And this gives us a problem because laptops don't come with serial ports anymore. About 20 years ago, they did, and serial ports were most commonly used to connect to old-style 56K modems. They don't exist anymore, so manufacturers don't put the ports on our laptops anymore. So how are we going to be able to plug this cable into our laptop? Well, what we need to do is buy an additional USB to serial adapter. So you can see
now these cables comes with USB, so USB-C or USB-B, USB-A, so you don't have to worry about these sort of things. I think he made this video way long time ago, so at that time USB-C were not that common. Now all the devices use common. And also I want to show you one USB-C cable, GDMI cable, CABLE, no, HDMI, new HDMI cable. Nah, these are again a Chinese company made one. GBMI, GPMI cable. GPMI. I think this is it. Nah, yeah. Yet integrated into a product, GPMI claims specification go well beyond existing wired standard. There are two protocol proposed type of GPMI cable level will stand USB connection known as GPMI USB type C, while the other appearance uses a new connection as GPMI USB. GPMI interface power supply. Yeah, GPMI. This is going to. If you go to YouTube and type GPMI, new connector that beats HDMI and DisplayPort.
Every PC builder debates between DisplayPort and HDMI. It can be a bit tricky. But there's a third option that very well could take over as the best choice. Apologies for being very late on reporting about this, but over in China, they developed GPMI, which could reign in the future as the high refresh 8K gaming king. This is general purpose media interface, and so far it comes in two flavors of connectors, one just being USB Type-C, the other being Type-B. That Type-B cable is what beats every cable right now in terms of maximum bandwidth. It can support 192 92 gigabit per second transfer and deliver up to 480 watts of power, which is kind of insane. Now, I know Thunderbolt offers a competitive solution for display output and power, but have you seen the prices of anything that's Thunderbolt certified? It is outrageous. GPMI is free of those dreaded licensing fees. In a world where there's HDMI 2.1, HDMI 2.2, DisplayPort 2.1, USB 4, Thunderbolt 4, Thunderbolt 5, etc., it would be amazing if we could all just standardize to one solution. That's probably not going to happen though. Every
USB 4? Did he just say USB 4? I've never heard of that. So USB 3, USB-C. USB 4 for long Thunderbolt. What does that mean? USB-C enable multiple devices to dynamically share a single high-speed data link. USB 4 defines the rate of 20. Oh, it's just USB-C with upgraded USB-C. Is USB-C the same as USB 4? No, USB 4 and USB 4 are not the same. Fuck you. USB-C is the physical connector chip, while USB 4 is a high-speed data transfer protocol. Oh, it's protocol, but they use the USB-C connector. Yeah, fucking that's what I told. But physically they are the same. I know I have used like USB 3.1 to 3.0, 3.0 and 3.1. iPhone uses, I think, USB 2.0. Anyway, let's not go to that rabbit hole.
See here, it has got a USB connector on one end, and it's got a male serial DB9 connector on the other. So we end up having the USB connector plugged into our laptop or our PC. That then has the cable going into the console cable with the serial connectors here, and then we've got the RJ45 connector that plugs into the router or switch. Okay, so Cisco realized that that's a problem because devices don't have those old-style connectors anymore. So with newer devices, it comes with a newer cable, which has got USB on one side to plug into your laptop and mini USB on the other side to plug into the device. Okay, so let's see how this looks on a router now. So I've got in front of me here an old 2600 router from Cisco. This used to be a very popular workhorse router. And you can see on the back here, where I've got my finger now, that is the aux or auxiliary port. And that used to be used for out-of-band management with those old 56K modems. Again, they don't exist anymore, so that doesn't really get used anymore, this port. Next to it, we have got the blue console port. That is where I've got my console cable plugged in. Then I've got a couple of onboard Ethernet ports on this particular router, and a couple of slots up at the top here where we can put in.
Basically, in the routers or a switch, you will get these sort of things. You see there is a screw. This is screw and this is screw. It has also got this screw and this screw. So this screw can take out. So he's only using one Ethernet port, but there's another kind of devices, or not devices, like a component of router. You can just plug in. Like if he's using one, there might be 2, 3, or 4. So the same goes for this one. They can use different ports as well. It's just a port removable, easily removable kind of.
Optional cards, and I happen to have an ADSL card fitted in here. Okay, so I have got my router there with the console port plugged into it, and you can see at the other end of my console cable, I have got my USB to serial adapter here, and I'm going to plug this end into my PC. Okay, so I've done that, and I've also plugged in the power lead in the router as well, so we're ready to make the initial connection to the device. The software that I'm going to use for that is Putty again, the same as what I used to make a connection over the network. I showed you in the last video how to download and install that. Just as a quick reminder, again, you can go to Google and just search for Putty download, and then the first link here, that is where you download and can install it from. Okay, so I've already got Putty installed on here, so I'm going to open up Putty. And the type of connection we need to use here to connect to the console port is serial. So I will click on that, and you can see it's showing in here the serial line and the speed. You need to select your correct COM port on your computer here. So the way you find out that information is open up Device Manager in Windows, and then look in your ports here, and you'll see the COM port, and it's usually COM3. Again, you need to have installed the driver software for the cable before this is going to show up. Okay, so I need to change this to COM3. Next thing is we've got the speed, and there's actually more settings in this. If you go to serial over in the main window in Putty here on the left, And there you can see again, I'm using COM3 for this connection, and I need to have the correct settings here. The default settings are actually okay. So the speed is 9600, I've got 8 data bits, 1 stop bits, the parity is none, and I should set the flow control to none as well. But if you leave the flow control as the default, it'll still connect anyway. Okay, so now I can go back to session up at the top here, and I can click on open. And I'm not going to see anything yet because I haven't powered my router on. So I'll just reach over here to the power switch on the back of the router, and I'm flicking it on now, and you can see now I start getting output from the router. So you can see that when you connect over the console connection, as soon as you power the device on, you're immediately connected to the command line and you can view the device booting up. This is going to take a few minutes to boot up here, so I'm going to speed up the video so we can watch it go through the boot up process.
Yeah, it
Okay,
takes
and
more
that
than a
is
few
the router
minutes.
fully booted up. And I see the message here, would you
you
like
can
to
see
enter the
more
initial
now.
configuration dialog? That's because I already factory reset this router. It's in the same state as if you bought a brand new router straight from the factory. So that's how you would connect to a new device and get to this prompt here and then start setting it up, putting on the IP addresses, etc. Now, hopefully it's obvious that it's not just for setting up new devices that you can use the console cable, and the device does not need to be powered off when you first connect to it. You could have a device that's already fully configured and powered on, and in your cabinet, you can connect to it with a console cable, and you will immediately get to the live command prompt. Okay, so that's everything I needed to show you about how to use the console connection. Okay, so you saw there that when we get a new device from the factory, we can connect to it with a console cable to do the initial configuration, including adding IP addresses, and we'll then be able to connect to it over the network later. But the console port is not just useful for the initial configuration of a device. You'll often see that it comes in useful for troubleshooting as well. So for example, let's say that we are trying to connect to an existing device on its IP address, but we cannot connect to it. Well, often one of the first things you'll do in that situation is you will plug into it with a console cable to see what is going on, because you don't need the IP address to be responsive to connect to it over the console cable. Another thing is if a device just appears to be completely unresponsive, but you can see that it is powering on. So that indicates that the device is probably failing to boot up. Well, again, trying to connect it over the network is not going to work because the IP address on the device is not live until it has completed the boot up process. So if it's not able to boot up, it doesn't have an IP address on there, you're not going to be able to connect it over the network. But what you can do is you can connect it with the console cable, then power the device on, and when you do it that way, you can watch the device booting up. So if it is having a problem completing the boot up, you'll be able to see what's going wrong over the console connection. Okay, that was everything I needed to tell you here. See you in the next lecture.
How many? I thought it's 23. Oh.
In this lecture, you're going to learn about how to navigate the Cisco iOS command line. Now, the way it's going to be done is through a live demo in the lab, and because I've got a heap of tips and tricks to show you for how to make your way around the command line, to save you taking your own notes as we go through here, I'm also going to attach a PDF, which is a summary of everything that we're going to cover here. The scenario you see here is I've got a brand new router, I've taken it out of the box, and I've hooked up a console cable, and then I've powered the router on, and it's currently going through the boot up process. And because it is a brand new router, it's going to ask me, would you like to enter the initial configuration dialog? If I entered yes here, it would take me to a command line driven wizard, which would help me do the initial setup. It's not commonly used. Normally we'll enter no here, so that's what I'll do here. Ask me, would I like to terminate auto install? Yes, I would like to terminate that. I'll see my interfaces on the router coming up, and then I land at the user exec prompt. Now, we're not commonly going to be working at the user exec prompt because there's a very limited set of commands that we can enter here. If I want to see what those commands are, I'll enter a question mark. So I just hit question mark on the keyboard there, and it shows me all of the commands that are available at user exec mode. Notice down at the bottom I see more here. This indicates that there's additional commands, additional output that I could see. I can hit the enter key, and that will scroll through it line by line, but this would be a fairly tedious way to scroll through a lot of output. So what I'll do instead is I'll hit the space bar, and that's going to scroll through it page by page. So I can just hit the space bar multiple times until I get to the end of the output there. Notice in PuTTY over on the right here, I can scroll back through the previous output. Now, by default in PuTTY, it doesn't include a lot of lines of scroll back. So what I can do to improve that is go up in the top left here, right click, and change settings. And if I then go to the window tab, I can set my lines of scroll back here to 2000. I've done that already. By default, you're going to see a much smaller value here. And that can be annoying because sometimes you do need to scroll back through quite a few lines of output. So I'd recommend that you set this to a high value. Okay, so you saw that I can hit the question mark to see all of the available commands that are available at this level in the command hierarchy.
Okay,
and as I said earlier,
I'm getting sleepy, man. I'm getting sleepy. Anyway, let's try finishing till section 4.
where there's not really a lot that I can do at the user prompt, so I'm going to go to privileged exec mode. To get there, the command I need to enter is enable. So I hit enable, and notice that the command prompt changes. When I was in user exec mode, the prompt showed the name of my router, which is just router, the default right now, and then a greater than symbol. But when I go to the privileged exec mode with the enable command, it changes to show the host
So user and privilege, and there's another one, configuration.
name and then a hash. So you can tell by the command prompt what level you're currently at. If I wanted to drop back down to the user level, which normally you wouldn't want to do, I can enter the disable command. Okay, so now I'm going to go back up to the privileged exec mode, which is also known as the enable prompt, and I'll show you that we can use command abbreviation here. So rather than typing in the full command enable, I can just say en and hit enter, and that will bring me back up. And I could also use an abbreviated command to go back down to the user prompt again, so I'll try entering di and hit enter, but what I see now is that this is an ambiguous command. The reason for this is whenever you use command abbreviation, there has to be just one possible unique match. So if I now enter di and a question mark, it will show me all of the possible commands that begin with di. And you can see that there's 3 possible commands here: dir, disable, and disconnect. So when I typed in di, it didn't know which one I meant. So if I wanted to actually put in the abbreviation for disable, I'd have to enter DISA, and it would now know, okay, there's only one possible command, I must mean disable. I don't need to go back down a level though, so I'll just stay at the enable prompt for now. Next up, I'm going to check what all commands begin with SH. So I'll enter SH and a question mark. And I can see there's only one possible command, which is show. On Cisco routers and switches, you will use the show command a lot because we use it to get information about the device. So the shortest way we can type that is just SH. If you want to see what the available show commands are, I'm going to put the same command in, but I'm going to have a space now. So it's SH space and then question mark. When you include a space, it shows you all of the possible keywords for that particular command. So this is the context sensitive help now. So again, I can see all my different show commands there. I'll hit the space bar to scroll through all the different options. If I wanted to break out of a command output without scrolling all the way to the end, I can hit the control button and C at the same time. That will break out of the command. And if I scroll back, you'll notice the first available option there was show AAA. So let's use that for our example and show you how you can figure out commands with the context sensitive help. So if I type in show AAA space question mark, it shows me all of the available options that would be available after show AAA. So if you need to enter a particular command, but you can't remember exactly what command you needed to enter, this can be really helpful in that situation. Similarly to the command abbreviation, we can also do tab completion as well. For example, you see my first option here is show AAA accounting stop cache. That's quite long to type in. So what I'm going to do instead is I'm going to say show AAA ACC, which makes it a unique match. And now I can hit the tab key and that will auto-complete the entire word for me. While I'm at the command line, I can use the backspace to delete what I'd entered already. So that's what I'm doing here. And let's deliberately put in a typo here. So notice I've put show AAA accounting stop quiche. That should be cache. I'll put in a typo. If I hit enter, you'll see I get the error message, invalid input detected. When you get this error, it's usually because you put a typo in. And I can see the marker here shows me exactly where that typo was. Let's have a look at another error. So if I do show AAA and hit enter, you see the error I now get is incomplete command. I have to carry on with the command by putting in one of these additional options here. If I do a show run question mark as an example, carriage return, that means that I could hit enter. These are all optional keywords. I don't have to enter one. I could actually hit an enter here to get some output. So at the enable prompt, that's where we'll most commonly be using show commands. The other main command we'll use here are debugs. So I could enter debug space question mark, and I'll see all of the possible debugs here. The difference between a show command and a debug, when you enter a show command, it gives you point in time information about the state right now. When you do a debug, what will happen is that the output will be updated in real time. So for example, if you were debugging OSPF and an OSPF packet came in, you would see it show up as and when the packet came in. Okay, next thing I want to show you is how to actually make configuration changes on the router or switch. At the enable prompt, that's mostly for information there. To actually make changes, we go to global configuration. To get there, it's configure terminal. Now the abbreviation for this is you can just type in conft. You'll use this command a lot, so you'll be using conft a lot as well. Okay, while we are in global configuration, let's hit the question mark, see all the available commands here. So we can do that the same as we did at the enable prompt. If I hit Control C to break out of this, another thing to notice is that the prompt changed again. So when we were at the enable prompt, the prompt showed our hostname and then a hash. When we're at global configuration, it's router and then config in brackets. So the hostname, config in brackets, and then a hash. Okay, we're up to the 10-minute mark in this lecture. I know when I'm learning, I don't like to sit too long. I like to take frequent breaks. So what I'm going to do for this lecture is I'm going to split it into 2 parts, which are going to be about 10 minutes each. So go get yourself a coffee and I'll see you back here for part 2.
So for this one, conft is it says interface. So interface will be gigabyte 0/0 or interface 0/0, interface 0/1. That's interface. Um, conft is where you can configure a lot of things, including our interface. So in a configure mode, you are going to configure an interface, but you have to be in that interface to configure. So to be into that interface, you have to type configure and interface and the interface ID. So G 0/0, G 0/1, those kind of things. And exit is go one label, in is to go all the way back to the normal one. Short version of command in yes, true, show is sh, command. Remember, you have to add a space in there. If you don't add any space, show IP will show you all available key option for the IP command. Moving cursor, backs delete, of course, error. Beginning, okay, that's something new I never tried. In CNF T. So now we are in configure mode. If we say sht do shint, yeah, so it shows gigabyte 0/0 down. Okay, let's say do shint br. Do sh let's say exit command A. I mean assets show interface. Okay. Show br. Sets t g 0/0 if. Okay. Control A. Okay. It's going to take you all the way to the beginning. So it does says that more. Delete the whole line. Oh, okay. If I do this, Control plus U. Oh, okay. Control plus A takes you to the front and deletes everything. Up and down, of course, it's the same. Show command output, scroll off end of the line, spacebar shows, CTRL will break out of the command output and return to the command purpose. So CTRL C, not only this one, so for example, right, I don't know which one now. Not only for this one, it works for lots of other programming as well. Even in a PowerShell, it will work in PowerShell command line. Running config interface. Okay, sure. Running config. run config int brief. Okay. Config t. Okay, it's not in the so it's why is it showing error in fast Ethernet? Okay. Pipe command example. That's router. Let me check. It also depends on the model, I believe. Yeah, not copying. Damn, unrecognized. Okay, it was looking for this one. Begin. Stay fast. Since there is no configuration, it's not showing it.
I want to show you how the command history works in a second. So I'm just going to enter a couple of random commands in here. It's just adding a couple of host entries. Don't worry too much about what this command does. It's not important. I'm just using this to illustrate the command history coming up in a second. So I'm adding IP host server 1 and IP host server 2. Next, I'm going to change the name of my router. I'm going to give it a host name, but I'm going to deliberately make a mistake here. So I type in router 1 and hit enter, and you'll see it tells me invalid input detected at the marker. It's because I forgot to say host name at the start here. So let's correct that. But rather than typing the whole thing in again, when you make a typo on a command, the quickest way to correct it is to hit the up arrow, and then that will bring the previous command back again. Now what I could do is I can use the left arrow to move the cursor to the left, but if it's a big long command, a way that you can do this quicker is by hitting Control.
Starting of the week, guys. Here I'm testing audio and visual. Peace out. No, I won't do it again. I'll delete all my accounts, delete everything. I won't never do it again. I'll never go on the internet again. I promise.
A, and that will bring you to the start of the line. So I hit the up arrow to get the previous command back, then Control A to move to the start of the line, and I can now type in hostname and a space, and that's the correct command now. So I hit enter, and notice that the prompt changes to reflect the hostname that I just entered there. Next, I'm going to show you command history. So I'm going to hit the up arrow a few times, and you'll see each time I hit the up arrow, it cycles back through my previous commands. That's why I entered those commands earlier. Notice that it only cycles back through commands at the same level. I'm in global configuration here, so it's cycling back through the commands I entered in global configuration mode. It doesn't show the commands that I entered at the enable prompt or in the user mode. Now I'm just going to delete this command to show you the next thing. While I'm in global configuration, if I try to do a show command, so let's do a show IP interface brief, and I hit enter and I get the invalid input detected. You know, I said earlier that where you'll most often see this is if you put in a typo. The other place where you'll often see it is if you're at the wrong command level. When you're a beginner, this is the most frustrating thing about the iOS command line. You'll make this mistake a lot where you're going to be at the wrong level when you enter a command. Our show and our debug commands are entered in privileged exec mode at the enable prompt. If I try to put it in global config, it's going to give me an error message. But this could be really annoying. So thankfully, there's a workaround for this when you want to enter a show command, because it is very common to put show commands in. And what I can do is I'm going to enter the same command, but I'm going to put do at the front. So again, I'm going to use the command history here. Rather than typing the whole thing in, I hit the up arrow to get the command back, then Control A to go back to the start of the line. Then I type in do and a space and hit enter, and you'll see that the show command is going to work now. And when you enter do, that will work from any level, unless you're actually in privileged exec mode. At privileged exec mode, you have to do the show command without do. At all the other levels, you put do in front of the show, and then it's going to work. So far we've seen the user exec mode, the privileged exec mode, also known as the enable prompt, and global configuration. There's other levels when you're configuring something specific on the router, meaning at global configuration, this is where I would do my global configuration for things that affect the router as a whole. If I wanted to configure a specific interface, I need to go to that level in the command hierarchy. So looking at my output here, I can see the interfaces I've got available on this router. If I wanted to configure interface fast Ethernet 00, for example, putting an IP address on there, I have to go to interface configuration mode. So to get there, the command is interface, and I'll use tab completion here. So interface fast Ethernet 0/0. And notice here that in the output above, fast Ethernet, that was capitalized at the start. Here, I don't need to use capital letters. iOS is not case sensitive. It doesn't matter if you use uppercase or lowercase, with one exception that we'll talk about a little bit later in this lecture. So I go to interface fast Ethernet 00, hit enter, you'll see that the command prompt changes again to show config-f, and I can see very clearly that I'm at the interface configuration level. If I want to drop back down a level, I enter the exit command, and that takes me back to global config. If I wanted to go to the enable prompt again, I would enter exit again, and that will drop me back to the enable prompt to privileged exec mode. Notice from here, I can enter interface fast Ethernet 0/0. This is going to give me an error message because you have to go up through the levels one by one. You can't skip straight from the enable prompt to the interface prompt. So I'll go back through the levels. So I enter config T to get to global configuration, and then interface fast 0/0 to get to the interface mode. So when you go up through the levels, you have to go one by one. When you drop back down the levels, you can actually do that all in one go. So it was exit to drop down one level. To drop all the way back to the enable prompt with one command, I can enter end. Another way I could have done that would be by hitting Control-C on the keyboard. Okay, a couple of the most common commands you'll use when you're working on a Cisco router or switch is the show IP interface brief that you saw earlier. That will show all the interfaces on the router and the state of the interface, whether it's up or not, and also the IP address configured on the interface as well, if there's an IP address on there. The other show command that is used really often is show running config. That shows the entire configuration on the router. And I'll hit the spacebar here to scroll through the configuration. And you can see even on a new router, it's a really long configuration file, and it's going to take quite a while to scroll through there. On a production router, it's going to be even longer because there's going to be actual configuration in there. There are switches we can use for the show run command, which are going to help us target the actual part of the configuration that we want to look at. For example, if I want to look at the configuration for a particular interface, I can do show run interface, and then the interface I'm interested in, and it shows me just that part of the configuration. So to see the interface config, it's show run and then interface and the interface number. The other switches that we can use on the show run command use a pipe. And to give you an example of that, I can do a show run and then the pipe symbol, which looks like that. And then the available options after there, the ones that are most commonly used, begin is probably the most commonly used. I can also include and exclude as well. So for example, I could do show run begin hostname, and this will show me the running config, but starting from where hostname shows up in the running configuration. Now, you know I said that there's an exception to when the iOS command line is case sensitive or not. But when you use a pipe, this is actually using a regular expression, which is case sensitive. So if I did a show run pipe begin, and try not to put a typo in, and then hostname with a capital H and hit enter, you'll see it's going to just go straight back to the command line again. This is not an error. The reason is that hostname with a capital H is not in the running config at all, so there's no output to show. To give you examples for the other pipe options, I could do a show run and then pipe it to include interface, and it'll show me all the lines that include interface, meaning the word interface in the actual output. I can also do a show run and pipe that and exclude interface. This will show me all lines from the configuration that do not include the word interface. And I can also do a show run and pipe and section interface. That will show me the configuration for all my different interfaces. Now, when you've got a production router, you're not going to just have interfaces configured on there. You'll have other things like routing protocols, for example. So I could also do a show run pipe it section and put in the particular part of the configuration I want to see here. Now, if you put in a question mark, it's not very useful here because it just tells you line telling you to use a regular expression. For example, I could put in section BGP to see information about the BGP routing protocol. I haven't configured it on this router yet, so I'm not going to get any output. But if I was using BGP on this router and I had a big long configuration on there, this would be a useful command because it would just take me straight to the BGP config and I could see that very clearly. Okay, so that's how to navigate the iOS command line. In the next lecture, we'll take a look at how to manage our configuration files. In this lecture, you're going to learn about iOS configuration management and the running configuration and the startup configuration. So I'm going to make some configuration commands to demonstrate this for you. I'm going to go to global configuration, so I enter config T. Notice right now that I've just got the default set up in this example where the hostname is router. If I enter the command hostname router1,
Alright, that's it for tonight. Peace out. Peace out.